Hello everyone. In this video we're going to be solving a polynomial system. We have a squared plus 3ab equals 40 and b squared plus 2ab equals 11. And we're going to be solving for a and b values. So if we had something like this, a squared plus ab is equal to 40 and b squared plus ab is equal to 9, it would be super duper nice. You know why? Because we could add these up and we would get a plus b quantity squared equals 49, and then we could go for a plus b, and then we could factor this, and so on and so forth. That would be really easy. This one is more challenging, and yesterday's video was very short, right? It was about 2.5 minutes maybe. So today's video is just going to be a little longer. So bear with me. I'll be presenting 3 methods. Even though the first and second are very, very similar, I'd like to present them. So let's start with the first method. So I'm going to rewrite the equations. A squared plus 3ab is equal to 40 and b squared plus 2ab is equal to 11. Obviously, at this point, you can guess and check if you know that the solutions are blank. Let me not tell you that. Anyways, for my first method, I'm going to use the idea that we always use for homogeneous equations. These are homogeneous equations. This is a homogeneous system, which means when you replace b with a multiple of a, it's going to be an equation in a different variable. Okay, anyways, I know I didn't really do a good explanation, but in other words, you can also look at it this way. This is quadratic, so it's homogeneous. So let's go ahead and replace b with k times a. That implies the following. A squared plus 3a times ka equals 40. Let's go ahead and simplify this. A squared plus 3ka squared equals 40. Let's go ahead and take out a squared. That's going to be helpful in a little bit. And let's do it one more time, this time for the other equation. B squared plus 2ab is equal to 11. And now we're replacing b with ka, so k squared a squared plus 2a times ka equals 11. This is k squared a squared plus 2k a squared equals 11. And then if you take out a squared like before, you get k squared plus 2k equals 11. Let's go ahead and copy the other equation here. Now we got two variables a and k instead of a and b. But this is nice because you can divide both of these equations and get rid of a squared and end up with a single variable, which is what is cool about homogeneous equations. If you divide these, you're going to get k squared plus 2k divided by 1 plus 3k is equal to 11 over 40. And if you cross multiply here, you're going to get a quadratic equation. Let's go ahead and do it. 40k squared plus 80k equals 11 plus 33k. If you put the 33k on the left-hand side, you get 47k, and then minus 11 is equal to 0. This is such a weird quadratic equation, and you'll be surprised when I give you the solutions. But this is factorable. If you check the discriminant, you're also going to realize, or use the quadratic formula, whatever. This is factorable as 8k plus 11 times 5k minus 1 equals 0. Great. From here, we can find the values of k very easily. K is either negative 11 over 8, or k is equal to 1/5. So we're going to go ahead and substitute both of these into one of our equations. For example, this one. Right? Because remember, we had two equations, this one and this one. And I'm just using the second one because it has less k in it. Doesn't matter, no big deal. So if I use negative 11 over 8 for k, I'm going to get 33 over 8 here. And guess what? 33 over 8 is larger than 1 or greater than 1. So this is going to be a negative quantity. But 40 is positive, 8 squared is positive, or it can't be negative. This is impossible, right? There's no way you can find a from here, which means the solutions are going to be complex. You can definitely go for it, but we're going to chase the real solutions. So the real deal. So in this case then, k equals negative 11 over 8 didn't work well. Let's go ahead and check k equals 1/5. If k is equal to 1/5, then we're going to get a squared times 1 plus 3 over 5 equals 40. This is 8 over 5. And 8 goes into 45 times, so we can go ahead and cross cancel and multiply, cross multiply. This gives us a squared equals 25. Nice. I like that. So from here, a is either 5 or -5. But remember, b equals a times k, and k is equal to 1/5. So if a is 5, then b is 1. If a is -5, then b is -1. So we got the solution pair, right? Great. So let's go ahead and take a look at the second method, since we finished the first one. And then I'll show you the third one, which is going to be real cool. And I'm also going to show you a graph at the end, which is really, really cool. All right, great. So I want to get rid of the constant. So let me rewrite my equation. My equations, rather. So I have this system. I want to get rid of the constants, 40 and 11. Can I do that? Absolutely. Because 40 times 11 is the same as 11 times 40. So let's go ahead and multiply the first equation by 11. Let's do it like this, so I can show you what is going on. Like this and like that. And let's multiply the second equation by 40. Like this and like that. And there you go. You got the same number on the right-hand side, which means you have the same expression on the left-hand side. 11a squared plus 33ab is equal to 40b squared plus 80ab. And these numbers should be familiar to you. Yes, those are the same ones as we got before in the quadratic equation. But anyways, to keep a long story short, let's put everything on the same side. How about the b side, or b squared side? 40b squared plus 47ab minus 11a squared is equal to 0. I just want to show you our quadratic so you can tell that the coefficients are exactly the same thing. Okay, that's why I call those methods very similar. They're not exactly the same thing, but very, very similar. Anyways, as before, you know that k is equal to -11/8. What is k though, right? Oh, that's the tricky part. Okay, great. So here's what we're going to do for k. I'm going to divide both sides by a squared. Let's do it. Divide by a squared. If you divide ab by a squared, you get b over a, and you get 11 here. And if you call this k, you get the same thing. Makes sense? 40k squared plus 47k minus 11 is equal to 0. And from here, you get k equals -11/8, which doesn't give you real solutions. K equals 1/5, which is b over a, gives you 1, 5, and -1, -5. By the way, this is a and this is b, as before. Great. Let's go ahead and talk about the third method without further ado, and we'll finish up with the graph. Okay. The third method is as follows. I have a squared plus 3ab is equal to 40. Let's isolate 3ab, write it as 40 minus a squared, and then divide both sides by 3a. And if you think I'm isolating b, you got it. Yes, this is b in terms of a. We could do that, right? And then the other equation is b squared plus 2ab is equal to 11. I can just go ahead and replace b with that. It's not going to be very pleasant, I got to tell you. But it's a solution, right? It's a solution, okay. So let's go ahead and do it. My writing became so messy. I'm kind of rushing. Rush. Okay, slow down. So that's my equation. And to keep a long story short, that's going to give you a quartic equation. But it's a bi-quadratic. If you simplify it, easy, you can do it. We don't have to spend time on that. You get the following quartic equation. But notice that there is no a cubed or a. So this is easy to factor. This can be factored into a minus 5, a plus 5, and 5a squared plus 64 equals 0. From here, it's easier to tell that this is not going to give us any real solutions, and the other solutions are as before. A equals 5 implies b equals 1. A equals -5 implies b equals -1. Let's go ahead and take a look at the graph, and we'll just wrap it up. Okay, so the graph that I made for you is, instead of a, I used x, and b, I used y, but it's the same thing. X squared plus 3xy equals 40. So those are two rational functions, and they intersect at 5, 1 and -5, -1, which are the a, b values. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.